Hello students, how are you? I hope all of you are good. In my previous video, I am discussing the introduction part for the exercise 10.2. In that, I discussed the first four concepts in my previous video. In that, the first one is triangle law of vector addition, and second one is parallelogram law of vector addition, and the third one is position vector of a point, and fourth one is direction ratios and direction cosines of a vector. So today in this video, I am going to discuss the next concept which are required to us to solve the problems in exercise 10.2. And the fifth concept required to us is unit vector along OX, OY and OZ axis and components of a vector and then vector joining 2 points. And next fourth concept is properties of algebra of vectors, and then last one is a section formula. So without wasting your time, let's start the first one. That is what? Unit vectors along OX, OY and OZ axis. First concept is unit vectors. Unit vectors along OX, OY and OZ axis. See here, as you know that this one is a Z axis, Y axis and X axis. So X axis, Y axis, Z axis, and this one is the origin. And suppose let A be the point on X axis at a distance 1 unit from the origin, and B is also one of the point on Y axis at a distance 1 unit from origin, and C is another point on Z axis at a distance 1 unit from the origin. Then definitely the coordinates of the point A. Then the coordinates of the point A is 1, 0, 0. On x-axis, y coordinate and z coordinates is equal to 0. Similarly, the coordinates of the point B, 0, 1, 0. And hence the coordinates of the point C is 0, 0, 1. Since on z-axis, x coordinate and y coordinate is 0. So see here, if I insert direction from origin to the point A, now it becomes a OA vector. And if I insert a direction from O to B, then it becomes a OB vector. And if I insert a direction from O to C, then it becomes a OC vector. And one more thing you need to observe here, the coordinates of the point A is 1, 0, 0, and magnitude of the OA vector. Magnitude of the OA vector is 1 because its length is 1. Because the point A at a distance 1 unit from the origin, and similarly magnitude of the OB vector is also 1 because B is at a distance 1 unit from the origin, and magnitude of the vector C is equals to 1 unit. And see here, I cap is one of the unit vector. I cap is one of the unit vector along the x-axis, and j cap is one of the unit vector along the y-axis, and k cap is one of the unit vector along the z-axis. It means the vector OA is equals to, magnitude of the OA vector is 1, but OA vector is I cap and OB vector is j cap, and similarly OC vector is equals to k cap. So it means we say that I cap is a unit vector along x-axis. So see here, unit vector along OX axis is equals to I cap, and unit vector along OY axis equal to j cap, and similarly unit vector along OZ axis is equals to k cap. I hope all of you understood this concept. Let's start the next concept. And the second concept required to us is components of a vector. Components of a vector. See here, to understand this, I am going to consider one of the example in a 2D plane. And the example is, as you know that this is a y-axis and this one is a x-axis origin. So here the example is, suppose a man starts walking from the origin to the point Q along the positive x-axis, and he stops at the point Q, and the distance between the point O and Q is 3 units. And then he started walking from the point Q along the positive y-axis, and he stops at the point P, and the distance between the point P and Q is 4 units. So observe here, OQ distance is 3 units, QP distance is 4 units. It means the coordinates of the point P is 3, 4. And now see here, the man started walking from the origin. So direction is from O to Q, and then Q to P. Therefore, direction is from Q to P. So it means, observe here, the distance between the point Q and O is 3 units. It means magnitude of this OQ vector is 3 units. But OQ vector should be equal to 3 into I cap. So we inserted I cap here because he is walking along the x-axis, and we know that unit vector along x-axis is I cap. So distance between the points O and Q is 3 units. But OQ vector is obtained by multiplying this I cap with the magnitude. And then the magnitude of this PQ vector is 4 units. But the vector QP is equals to 4j, because j is nothing but unit vector along this y-axis. I hope all of you understanding. And one more thing you need to observe here, as I discussed in the previous video, if P is a point, then its position vector must be a OP vector. So direction from O to P. Now observe here, OQP is one of the triangle, and from the triangle of vector addition, here OQ and QP are the two adjacent sides of the triangle, and this third side OP vector is taken in reverse of these two vectors. It means this OP vector is the resultant of these two vectors OQ and QP. Therefore, from the triangle law of vector addition, from triangle law of vector addition, definitely OP vector should be equal to OQ vector plus QP vector. Therefore, OP vector is equals to, here the OQ vector is 3I cap plus OP vector is 4j cap. And this is what? One of the vector. And this is called as component form of the vector. And this form is called as component form of vector. This is a component form of the point which is in 2D plane. Suppose if you want to find the component form of the point which exists in the 3D plane. So let us consider one example. Let us consider one example which exists in the 3D plane. So let A be a point in a 3-dimensional plane, and whose coordinates are, I am going to consider in a general form, suppose x, y and z. So x coordinate of the point A is x, and y coordinate of the point A is y, and z coordinate of the point A is z. So as you know that position vector of the point A is, position vector of point A is equals to OA vector, and the component form of OA vector is x into I cap, x coordinate of the point along with unit vector along x-axis, plus y coordinate of the point A along with unit vector along y-axis, plus z coordinate of the point A along with the unit vector along z-axis. So this is called as, this form of the vector is called as component form of the vector. Component form of the vector. And one more thing you need to observe here, the coefficients of I, j and k are called as scalar components of the vector OA. ಏನಂತ ಕರಿತೀವಿ? Scalar components. Scalar components of the vector OA is x comma y comma z, and vector components of OA vector, vector components of OA vector is equals to x I cap and y j cap and z k cap. I hope all of you understood. So let us consider one example. See here, suppose write the position vector, and scalar components and vector components of the point point R whose coordinates are given by 5, 1, -3. So as you know that position vector of the point R is OR vector, and its component form is given by 5 into I cap plus 1 j cap minus 3 k cap. So which is a component form of this OR vector. And in this OR vector, the scalar components are scalar components are coefficients of I, j and k. That is nothing but 5, 1, -3. They are nothing but the coordinates of the point R. So first one is 5, 1 and -3. And then the vector components of OR vector. Here vector components of OR vector is 5 I cap 5 I cap and then 1 j cap and then minus 3 k cap. I hope all of you understood the components of a vector. If suppose A is one of the point x, y, z, its component form is given by position vector of the point A, that is what OA vector, and OA vector is xi plus yj plus zk. And in this component form, the coefficients of I, j and k are called as scalar components of the OA vector. And then along with I, j and k, xi, yj, zk are called as vector components of the OA vector. I hope all of you understood this concept. So let's start the next concept. Next concept required to us is vector joining 2 points. Vector joining 2 points. Vector joining 2 points. See here, to understand this, I am going to consider the graphical approach here. So as you know that this is a z-axis and y-axis, and this one is a x-axis. So x-axis, y-axis, z-axis, which is the origin. And we need to identify the vector which joins the point P and Q. That is nothing but PQ vector. So we need to identify the vector PQ. So direction from P to Q. As you know that position vector of the point P is OP vector, direction from O to P, and position vector of the point Q is OQ vector, so direction from O to Q. And let's suppose coordinates of the point P is x1, y1, z1, and point Q is x2, y2, z. Now observe here OPQ is one of the triangle, and in this triangle vector OP and PQ vector are the two adjacent sides of the triangle OPQ taken in a cyclic order. It means this third side OQ vector is the resultant of these two vectors OP and OQ vector. Therefore, from the triangle of vector addition, from triangle law of vector addition OQ vector is equals to OP vector plus PQ vector. I hope all of you understood. So we need PQ vector. So from this equation we can write PQ vector is equals to OQ vector minus OP vector. See here, PQ vector is equals to position vector of the terminal point minus position vector of the initial point. Similarly, if you want to find the vector joining 2 points A and B, that is AB vector. And suppose AB vector is equals to OB vector minus OA vector. And similarly, TU vector joining the points T and U is equals to position vector of the point terminal point OU vector minus OT vector. Similarly, if you want to find the vector joining 2 points X and Y, that is XY vector, which is equals to position vector of the terminal point Y minus position vector of the initial point X, that is OX vector. I hope all of you understood. One more thing you need to observe here, coordinates of the point P is x1, y1, z1. Coordinates of the point P is x1, y1, z1, and coordinates of the point Q is x2, y2, z2. x2, y2, z2. And as you know that position vector of the point P is OP vector, and its component form is x1i plus y1j plus z1k, and position vector of the point Q is OQ vector, and its component form is x2i plus y2j plus z2k. We need PQ vector. So here PQ vector is equals to, we know that PQ vector is equals to OQ vector minus OP vector. I hope all of you understanding. So therefore PQ vector is equals to, OQ vector is x2i plus y2j plus z2k minus, multiply this OP vector by the minus sign, it becomes minus x1i minus y1j minus z1k. Therefore PQ vector is equals to x2i minus x1i. It is nothing but x2 minus x1i cap plus y2j minus y1j. So y2 minus y1j plus z2k minus z1k. Z2 minus z1k. So this is what PQ vector. This is vector joining the 2 points P and Q. And see here the scalar components are x2 minus x1, y2 minus y1, z2 minus z1, and other name of the scalar components is nothing but direction ratios. Here the direction ratios andru onde as well as scalar components andru onde. So here the scalar components or direction ratios of the PQ vector is what? X2 minus x1, y2 minus y1, and z2 minus z1. I hope all of you understanding. And as well as in my previous video I discussed the direction cosines. The direction cosines of the vector PQ. Direction cosines of PQ vector, that is direction cosines are denoted by L. And L is equals to direction ratio x2 minus x1 divided by magnitude of the vector PQ, and the value of m is equals to coefficient of j, that is what, y2 minus y1 divided by magnitude of the vector PQ, and similarly the value of n is equals to k coefficient z2 minus z1 divided by magnitude of PQ vector. I hope all of you understood this vector joining 2 points. Next concept is properties of algebra of vectors. Algebra of vectors. Algebra of vectors is nothing but addition, subtraction, and multiplication of the vectors. So here I am going to discuss only addition and subtraction. Multiplication of vector, it will becomes in next exercise. See here, properties of the vector addition. Suppose A is one of the given vector in component form a1i plus b1j plus c1k, and another second is a b vector and its component form is a2i plus b2j plus c2k. So here first we need to find a vector plus b vector. A vector plus b vector. So a vector plus b vector is nothing but a1i plus a2i plus b1j plus b2j, c1k plus c2k. It is nothing but a1 plus a2i plus b1 plus b2j plus c1 plus c2k. Similarly, a vector minus b vector is equals to a1 minus a2i plus b1 minus b2j plus c1 minus c2k. I hope all of you understanding. And the third one, we say a vector is equals to b vector, that is nothing but a1i plus b1j plus c1k is equals to a2i plus b2j plus c2k. See here, these two vectors are said to be equal if corresponding coefficients of I, j and k are equal. It means A1 should be equal to A2, B1 should be equal to B2, C1 should be equal to C2. Then we say that the A vector is equal to B vector. And the fourth one is, A vector and B vector are collinear if A vector is equals to lambda times of B vector or B vector is equals to lambda times of A vector. So let's suppose I am going to consider this first condition, A vector is equals to lambda times of B vector. So here the A vector is A1I. So each implies A vector is A1I plus B1j plus C1k equal to lambda times of B vector. B vector is A2I plus B2j plus C2k. And see here, A1I plus B1j plus C1k is equals to lambda into A2I plus multiply lambda with each and every terms inside the bracket, lambda into A2I plus lambda into B2j plus lambda into C2k. Now observe here, first vector A1I plus B1j plus C1k equal to lambda A2I plus lambda B2j plus lambda C2k. So these two vectors are related by the sign equal. By the definition of equality of vectors, corresponding coefficients of I, j and k are equal. It means that A1 should be equal to lambda times of A2 and B1 should be equals to lambda times of B2 and C1 should be equals to lambda times of C2. And from this here, first one, we can say that A1 divided by A2 is equals to lambda and B1 by B2 is equals to lambda and C1 by C2 is equals to lambda. So by these three relations, we may say that A1 by A2 is equals to B1 by B2 is equals to C1 by C2, and this is also one more condition for the collinearity of two vectors. See here, two vectors A and B vector are said to be collinear if first vector is equals to lambda times of B vector or second vector equals to lambda times of the first vector or A1 by A2 equal to B1 by B2 equal to C1 by C2, where A1, B1, C1, illodri, A1, B1, C1 are what? Direction ratios of A vector, and A2, B2, C2, A2, B2, C2 are the direction ratios of B vector. If the corresponding direction ratios of first vector and second vector are proportional, then also we say that the given two vectors are collinear. I hope all of you understood. Last concept required to us is section formula. So one of the most important concept. So in your annual examination, they may ask proving for the section formula or the problems which are solved by using the section formula. In this video, I just discussed the section formula, but in my next video, I will definitely prove the section formula. See here, what is the concept of this section formula? So let O be any fixed point and PQ is a vector joining 2 points P and Q. PQ is any vector which joins the point P and Q. And suppose R point, suppose the point R divides this PQ internally in the ratio M is to N. In the ratio M is to N. Then we need to find the position vector of the point R. Then we need to find the position vector of the point R, that is OR vector. Here what is the condition? PQ is any vector and R is one of the point which divides this PQ internally in the ratio M is to N. Then we need to find the position vector of this point R, that is OR vector. So we need to identify the vector OR here. So here, as you know that position vector of the point P is OP vector. Let's suppose OP vector is equals to A vector. Let's suppose OP vector is equals to A vector, and position vector of the Q point is OQ vector, and let's suppose OQ vector is equals to B vector. OQ vector is equals to B vector. See here, if the point R divides the line segment PQ in the ratio or internally in the ratio m is to n, then position vector of the point R, that is OR vector, is equals to m into B vector plus n into A vector divided by m plus n. This is a position vector of the point R when it divides the PQ internally in the ratio m is to n. Suppose this point R divides this PQ externally in the ratio m is to n. Then what is the position vector of the point R? See here, the formula for position vector of the point R when it divides this PQ externally in the ratio m is to n is OR vector is equals to m into B vector minus n into A vector divided by m minus n. I hope all of you understood the concept which are discussed in this video.